Hey guys, today we are going to continue looking at multiple representations of additive or multiplicative patterns. And previously we were given all of the representations, but today we are just given a verbal story problem. And we're going to use that to generate all of the different representations, which are verbal, algebraic equation, table, and graph. So we have Corey here, and he spent spring break fishing at Lake Texoma. And each day he caught 4 fish for each hour he spent fishing. You know, and I think that that's important, that he caught 4 fish every hour that he was fishing. We want to know, how can this situation be modeled with the 4 different representations? And so I see the verbal one. It says the number of blank caught depends on the total number of blank spent. So they're wanting us to identify our independent and our dependent variables. So my independent variable and my dependent variable. And so we're talking about 2 different things. We're talking about time, and we're talking about the number of fish. And the number of fish I catch is going to depend on the time that I'm out there. The more time that I'm out there, the more fish that I catch. And the less time I'm out there, the less fish that I would catch. So when I go to fill in the blank, it's the number of fish caught depends on the total number of hours spent fishing. And what they're really having us do is identify our X and our Y right here. Right, so independent variables are X, dependent variables are represented with Y. So we want to make a table now. And really, it doesn't matter which way we go. We could go verbal straight to the graph or verbal to the algebraic equation. It does not matter because they're all representing the same thing. And so actually, I see that algebraic equation really builds on some of the stuff we've already done. So F represents the number of, and we know that that's going to be fish. And H represents the number of hours. And as far as our equation right now, I'm going to leave it blank, but we will come back to it. So our table, we have hours in the left-hand side, and we have fish in the right-hand side. And notice they've already filled in this 1 hour right here. And based on what I had highlighted in my story problem that I thought was important, I know that in 1 hour, Corey gets 4 fish. So I can continue that pattern. So in 2 hours, he would get 8 fish. In 3 hours, that would be 12 fish. 4 hours would be 16 fish, because every hour I'm increasing by 4 fish. And 5 hours would be 20 fish. Now that I have a table to look at, I'm thinking I can write an equation pretty quickly. And I see right off the bat that this is not additive, but it is multiplicative. And it's 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. And 5 times 4 is 20. So I'm taking the hours and I'm multiplying it by 4 to find the number of fish. So I can use that to go fill in my algebraic equation. So we have F, which is fish, is equal to 4 times the number of hours. So I can represent it with the dot in between the 4 and the H, symbolizing multiplication. Or I can just say the 4 is in front as a coefficient, and that still means the same thing, we're multiplying. And last, we have our graph. And I see that there's blanks so that I can label my axes. So I'm going to label my x-axis as hours and my y-axis as fish. And I see that there aren't numbers. So when I go to label my numbers for hours, I know that we just kept going up by 1 every time we increased by 1 hour. So I will start at 0. I'm going to go up to 1 hour, then 2 hours, 3, 4, and 5. Now for fish, every time we went up by 4. So I'm thinking that's going to be what I want my y-axis to increase by. So from 0 to 4 to 8 to 12 to 16 and then to 20. And I can take the values in my table, which form a coordinate pair, and put them on the graph. So I know if Corey spends 0 hours fishing, he catches 0 fish. So that's the point at the origin. And that's this whole idea that when it's multiplicative, it will go through the origin, it will go through that point 0, 0. At 1 hour, Corey had 4 fish. 2 hours, he had 8. 3 hours, 12. 4 and 16 fish. And at 5 hours, he caught 20 fish. So here's how we're able to take a story problem or take any representation and represent it in multiple ways. Thank you.